today's topic that we are going to do is ratio and proportion. Let's start by understanding what is actually ratio and what is proportion. Now, what is this ratio and proportion? Many of the times we hear that the marks of a student in English and maths is in the ratio of 2 is to 5. That means if he has secured 20 marks in English, he has secured 50 marks in maths. Or you can say that the age of two different students, is in the ratio of 12 is to 15. So that means if one student is there who is of 6 years, the other one is a multiple of 5. So what is ratio and proportion in maths? You may find a lot of examples such as the rate of speed or price of a material, etc., where the concept of ratio is highlighted. That is numerator by denominator. A fraction is generally referred to as a ratio. And when I'm talking of a proportion, proportion is an equation which defines that two given ratios, that one ratio on the left side and the other ratio on the right side, they are equivalent to each other. So ratio is a fraction, and if we put an equal to sign in between, it forms a proportion. For example, the time taken by a train to cover 100 km per hour is equal to the time taken by it to cover the distance of 500 kilometers for 5 hours. So we can write down 500 kmph is equal to 100 kmph is equal to 500 by 5 hours. So that is how, when an equal to sign has been added, just try to understand that when an equal to sign gets added, earlier if I'm talking, we are saying that 500 divided by 5. That is, he's traveling 500 kilometers in 5 hours. So if I'm putting an equal to sign, this is actually, if I'm just talking of this particular term, this is called as ratio. But now I am saying that it is 100 kilometers he's traveling in 1 hour. This on the right side, this is also ratio. But now, how are they going to be referred to as a proportion? Because I am putting this equal to sign, so this entire thing is going to be called for proportion. Is that clear? Then we will be talking of definition of ratio. Now, in certain situations, the comparison of two quantities by the method of division is very efficient. We can say that comparison or simplified form of two quantities of the same kind is referred to as ratio. Now, very important one thing over here is that the two quantities should be of same kind. That is, if you're putting up in a fraction, if you're putting up the lengths, they should be lengths only. The numerator and the denominator should be length only. Now this relations give us how many times one quantity is equal to the other quantity. I told you that we say that age or marks of a student in English and maths are in the ratio 2 is to 5. So we are getting the comparison between the marks of English and maths. So that is why we say that we can easily compare and we can easily put it into a simplified form if we are referring to them as in quantities. This relations gives us how many times one quantity is equal to the other quantity. That is, the marks of English is, if the marks of English is 2 times, then the marks of maths are 5 times. The two numbers in a ratio can also be expressed when they have the same unit. And what is the sign that we use to denote a ratio? It is this thing. That is this. This is how we use up by defining a ratio. That is, I'm saying that the marks of English and maths is 2 is to 5. So what is it? We are going to represent it in this form. You can even say it like this, or you can even say 2 is to 5. So it is up to you which format do you prefer, this one or this one. Now there are some points that we need to remember. They are that the ratio should exist between the quantities of the same kind. I told you, if I'm talking of this kind, that means if I'm comparing lengths, the numerator and the denominator should be lengths only. I was taking over here, I was taking marks, so they both numerator denominator should be marks only. If I'm comparing the age, numerator denominator should be age only. If I'm comparing the weight, they should be weight only. Second, when we are comparing two things, their units should also be same. That is, if I'm talking of length, now if I'm talking of length, and suppose the numerator is in centimeters, then means we should have the denominator also in centimeters. Yeah, it should not be the case that numerator is in centimeter and the denominator is in kilometers. No, then you need to change the units. You need to put it into the correct format. Then there should be a significant order of terms, and the comparison of two ratios can easily be performed, that we have already discussed. Clear? Then definition of proportion. Now proportion is an equation which defines that two given ratios are equivalent to each other. I said that we are going to put an equal to sign in between, then the ratios will get converted into a proportion. If two sets of a given number are increasing or decreasing in the same proportion, then what do we say? Or in the same ratio, then we say they are directly proportional to each other. That is, if the numerator and the denominator of both left hand side and RHS are increasing or decreasing by the same proportion or the same ratio, we say they are directly proportional to each other. The example, I have just taken the same example, that train is covering 100 kilometers in 1 hour and 500 kilometers in 5 hours. Now ratio and proportion, they are said to be faces of the same coin. That is, when two ratios are equal in value, they are said to be in proportion. And what is the symbol that we use up? The symbol that we use up over here is this, either double colon or equal to. Is that clear? Now let's just move on to the next part, that is ratio formula, and then we'll be talking of the proportion formula. Now when I'm talking of the ratio formula, assume that we have two quantities and let that quantities one be A and the other be B. So the ratio, I have already told you that it is going to be A is to B, and that is A is equal to B. A divided by B, and the numerator is going to be called as antecedent and the denominator is going to be called as the second term or the consequent. Then they have given the example that in a ratio that is 4:9, can also be easily represented as 4 by 9, where we are going to call 4 as the first term or antecedent and 9 is going to be called as consequent or the second term. And one thing more, if we are going to multiply numerator and denominator by the same non-zero number, always remember same non-zero number, then we can say that it is not going to affect our ratio. Now suppose the ratio was of 4:9. Now if we are going to multiply numerator and denominator by 2, we can easily write that 4:9 is equal to 8:18. Or if we are going to multiply it by 3, then we can easily say that it is equal to 12:27. So non-zero and same number multiplying in the numerator and denominator. Then proportion formula. Now let us assume that in a proportion there are two ratios, A is to B and C is to D. Now B and C, that is the mean terms, the middle terms, they are going to be called as the mean terms. This one and this one, they are going to be called as mean because they are in the center. And A and D, because they are at the ends, so they are going to be called as extremes. Clear? Then we have an example that there is a classroom and this ratio of girls is to boys is 3:5 and 4:8. then the proportion can easily be written in this format, that is 3:5 is equal. Now you can put up this sign or you can put up this sign. Over here 3 and 8 are going to be called as extremes, and 5 and 4 are going to be called as means. And if you're going to multiply numerator and denominator, or you're going to multiply or divide numerator denominator by any same non-zero number, it is not going to affect either the ratio or the proportion. Clear? Then there are some important properties of proportion. Like if we are assuming that what we have is somewhat like this: A is to B, double colon. This is known as colon, and this is known as colon, and this is known as double colon. You may even represent this by writing it like A by B is equal to C by D. So what do we get over here is addendo. The first thing is addendo, that is adding. So that is this A plus C is going to addendo of this particular proportion will be A plus C by B by D. If you have to calculate subtrahendo, it will be A minus C divided by B minus D. Then if it is going to be dividendo, you have to subtract, and in the numerators you will be writing the subtraction of the numerator and denominator on both the sides. This is componendo. You're going to add कहाँ पे करना है? In the numerator you are going to add the numerator and the denominator and put the denominator as such. Then alternando, you're going to alter the terms, that is B will take the place of C and C will take the place of B. Invertendo, then B will take the place of A and A will take the place of B. So inverting the same ratios. Then componendo and dividendo. Componendo means we have to add, dividendo means we have to subtract. Then plus terms in the numerator and subtraction terms in the denominator. They are going to be used like they might give you they might give you some kind of ratio and they are or proportion equation, and they may ask you apply invertendo and tell me what are the results and certain things like that. Clear? Then differences between ratio and proportion. Now when I'm talking of ratio, it is used to compare the size of two things which are in the same units, and proportion, it is simply used to express the relation of two ratios, whereas we are comparing in a ratio, and proportion may we are just trying to make a relation of two different ratios. It is expressed by a colon or a slash, and on the right side as a proportion it is expressed using double colon or equal to sign. Ratio is an expression, whereas proportion, because there is an equal to sign, so it forms an equation. Now the keyword to identify any ratio is that to every single girl present in a class there are two boys, whereas in a proportion, so out of 600 students 30% are boys or 30% are girls. So that is how we are going to identify which is a ratio and which is a proportion. Then some of the other important applications of proportion or ratio and proportions are, now if we have that A is to B is equal to C by D, then D is going to be called as the fourth proportion ABC, C is going to be called as third proportion. And if you are asked that write down the mean proportion of this, mean proportion of the RHS or the LHS will be square root of AB. That is how we calculate the mean proportion. And if you're going to compare ratios, then simply comparison means that one ratio is greater than the other and one ratio is lesser than the other. So you can simply put a slash and you can represent. Now there are certain duplicate ratios. Now if you have A is to B is a ratio, that is A is to B is a ratio. Now for this ratio, what we say, There is a duplicate ratio, there is a subduplicate ratio, and there is a triplicate. Duplicate means you're going to square the things. So for a is to b, if it is a ratio, then a square and b square is going to be the duplicate ratio. Subduplicate, that means you're going to take the square root. That is, if you have, suppose 4 is to 9 is the ratio given to you. Then I'll just take this example. I'll just take it after. And the triplicate ratio will be then when you are going to take the cube root. You're going to do the cube. Now suppose, let us just assume an example that you have, this is the ratio. Now to find a duplicate ratio, what you're going to do is, what will be your duplicate ratio? It will be 16 is to 81. That is going to be the duplicate ratio. That is, you are simply squaring down whatever values you have. Then subduplicate ratio, that is, you are going to do the square root subduplicate ratio. So doing the square root, 4 square root is 2, 9 square root is 3. So this is going to be the subduplicate ratio. Now the triplicate ratio, that is, you're going to do the cubes of the numerator denominator. So 4 cube is 64 and 9 cube is 729. I hope this concept of ratio and proportion is clear enough to all of you. Thank you for joining in.